Hello, everyone. Today I'm with Ishaq Zaighum, one of our amazing fellows from class 31 serving at SeedSpot, and he will be giving us some tools, some statistical tools for impact measurement. If you have any questions, write them down, and Ishaq will be happy to answer all of them. Ishaq.
Thank you so much, Ons, for providing me this opportunity to interact with amazing family of fellows, and thank you, Atlas Corp, for this opportunity. My name is Ishaq Zaighum. I am an Atlas Corp fellow from class 31 from Lahore, Pakistan. A brief background of myself. I am a development professional. I was working with a USAID funded project back in Pakistan. Like for more than 5 years, I have worked for different USAID funded projects, particularly carrying out monitoring and evaluation activities for the project that involves data analysis, survey designing, like some different field activities, data collection, report writing, and stuff like that. As far as my educational background is concerned, I have completed two master's degrees, one in project management, the other one in applied statistics, fortunately with academic distinctions, including gold medal and academic roll of honor and rector's award. So this is a brief introduction of my academic background and professional background. And today I'll be presenting on a very important topic, providing an introduction, a brief introduction to some of the very useful statistical tools that are available in MS Excel. Very easy to use and very helpful to carry out impact measurement. And if your organization is working to create some impact, some social impact, and you have certain indicators in place, and you frequently conduct your surveys, then this presentation is going to be very helpful for you. And for all those who are working with different organizations across United States, working in social sector or in different sectors, I think this presentation will be relevant to all of you. So I think I'll be starting my presentation right now. So I'll share my screen with you. Yeah, so the topic of the presentation is introduction to some statistical tools for impact measurement using MS Excel. So briefly, I will discuss the contents of my presentation. I will discuss what is impact measurement, why it is important very briefly, and then I'll be sharing with you a very useful add-in, which is a feature in MS Excel that is basically used to carry out some statistical analysis, along with the help of a practical example that how to carry out that analysis and how to actually measure the impact of the projects or organizations interventions or activities. And then I'll be sharing an example with you that how we can compare across two categories of a variable. For example, if you want to draw a comparison based on the gender of your beneficiaries or respondents or participants, or like their ethnicities or like their location, the cohort, or any other like categorical variable that you have, and you want to draw a comparison across different categories, then that statistical tool is going to help you for that. So very briefly, what it means when we say impact measurement. So impact measurement is a process of quantifying the results of intervention. So by intervention, I mean that like any activity that a project or an organization carries out to create some results, to create some like output, some outcome, or some impact. So analyzing what effect an intervention such as a funding program is having on people or organizations, etc. So this is basically a process to analyze the effect or the results of an interventions of one or more than one activities that a project or an organization is carrying out. It is as simple as that. Why it is important? It is important to know what has changed Like this process is very important to know that your what kind of impact your organization is creating, and it can help you to quantify the effect or the results that are being created as a result of your organization's activities or operations or interventions. It also helps to know what works about an intervention. So if you have different activities planned for your organization, or if your organization is involved to carry out like different kinds of operations or interventions, then impact measurement is going to help you to know what is working, what is not working, and what is the status of your activities, and what kind of results your activities are actually like creating. And it will also help you to know the extent and intensity of the change. This is very important. So although some of the activities that an organization is doing that might be creating some impact or some results, but it is also very important to know that to what extent the result is being created, what is the magnitude of uh, the impact that is being created, and how significant is that impact, how intense or how considerable is that impact or that change that is being created as a result of your organization's activities. Also, it helps you to benchmark and make comparisons. Again, for example, if you are measuring the impact of your organization's work, let's say after 5 years, then you can set a benchmark, or like kind of you can set a baseline um, that you can compare your results with in the next 5 years. For example, if you have carried out an impact measurement after the 5 years of your organization's work, then you can again do a similar kind of impact assessment and impact measure maybe after 10 years, and then you can compare that uh, the results of that impact measurement with the previous results that you had before. So it also helps you to benchmark and make comparisons. And also you can learn and make improvements. For of course, this is very important, that it helps you to see where do you stand, what is working, what is not working. When you see all the results in front of you, then you are able to learn, you have some lessons, and you can make improvements in your design, in your program design, in your interventions, in your activities, so that you could produce even better results in future. It also helps you to test some assumptions and hypotheses. So, for example, if you have certain assumptions, if you want to test certain hypotheses that, for example, your work or your activities are creating impact in a certain community, or they are, for example, if you are supporting female entrepreneurs, that what kind of impact your female entrepreneurs are creating in the society. For example, how much revenue they are generating as compared to the male entrepreneurs. For example, how much donations or grants they have received as compared to their male counterparts, and other variables that you can use for comparison, and other kind of hypotheses that you have set. You can test those hypotheses as well. So how can MS Excel help you to do all this impact measurement work, benchmarking, testing assumptions and hypotheses, etc. I have chosen to use this software because it is the most frequently used spreadsheet software in comparison to like any other statistical software. For example, although you have a variety of statistical softwares available that you can use to carry out like detailed and more comprehensive statistical analysis, for example, SPSS or like Minitab or eViews or Stata or any other softwares, but since most of the organizations don't have these statistical softwares, so and most of the organizations provide MS Excel to their staff to carry out like to keep their data, to record the data, to carry out analysis. So this is going to provide a very like kind of user friendly tools and techniques and interface which is accessible to like most of the people working in different organizations. And it also provides a range of statistical analytical tools. So it has different add-ins that you can install like free of cost, and you can use a variety of statistical tools that are there that can help you in measuring the impact of your interventions and work. and it is very easy to carry out analysis and interpret results because it's a very user-friendly software. You don't have to be an expert in statistics to use MS Excel or different tools that MS Excel provides. So if you just know like the basics of how to use this spreadsheet software, then it will be very easy to use that add-in and utilize different statistical tools that are there in the data analysis add-in, which is basically which is called data analysis tool pack. I'll be talking about that in the coming slides. So this data analysis add-in, which is called data analysis tool pack, how you can install it. If you use a Windows computer, then you can go to the file from the menu bar and you can select Excel options, and you're gonna see a window like this in front of you. So if you go to the second and last option, which is add-ins, you can select analysis tool pack, which is the second option highlighted here in the window. You can click OK, and this particular add-in will be installed right in your menu bar. And or if you use MacBook, you can go to the tools and you can then install this add-in using a similar kind of process. So once you install it, you can see that here this option of data analysis will pop up on your toolbar. So once you click on it, you're going to see a window like this, which provides you different kind of statistical tools. For example, you can draw histograms, moving averages, random number generation. You can calculate rank and percentile, regression sampling, and some of the statistical tools. But some of the tools that I'll be focusing on during this presentation are descriptive statistics, correlation, two sample comparison, which is basically a t-test. And although I have written analysis of variance and regression analysis, but mainly we'll be focusing on some descriptive statistics and two sample comparison, which is t-test. So let's take a hypothetical example in which, for example, your organization has supported 100 entrepreneurs by providing them trainings and mentorship in the past years, and you have conducted a sample survey to see where do these ventures stand in terms of the following. So you have set certain economic indicators against which you are interested to measure the performance of your organization or the project, and those indicators are annual revenue, grants, donations that your beneficiaries have received, how many jobs have been created as a result of your activities and support and intervention, or what is the team size of the businesses that you support, and how many lives are being impacted or have been impacted as a result of your support. So these are some of the indicators that you have, your metrics against which you are gonna measure the progress of your project or organization. So, for example, you have selected a sample of, let's say, 30 um, participants or 30 beneficiaries among your target population of 100 beneficiaries. You have their locations with you, so you conducted your activities in different locations in different cities across the United States, in different cohorts, and you have this information regarding their gender, regarding their ethnicity, this demographic information. In addition, you have your economic indicators available with you that you collected the information against using a sample survey. So, for example, you have the total revenue in thousand US dollars. Similarly, the grants, donations that a particular beneficiary or a participant has received. You have the team size, how many people are working in the team, and the lives impacted, how many lives the businesses have impacted so far. So this is just a hypothetical data available with you. So how you can analyze this data to measure the impact or to carry out the analysis in MS Excel. So if you go to that option of data analysis that is right there on the toolbar, that using that in that we just installed, so you're going to see a window like that in front of you. So here you can see a couple of options available here. First of all, you're going to provide the input range of all the variables that you have. So you click on this icon of input range on the on this like row. So once you click on this icon, you will be able to select all these columns, including their labels, to the last cell that has any value in it. And you will be selecting group by as columns because you have all the information in columns, and you have their labels as well. So you're going to check this options labels in first row, and you can provide the output range where you want to paste the output or the results, either in the same worksheet or in a different workbook. So you can like provide the range or the cell address here. And once you are done with that, you can click OK. If you want summary statistics, you can check this option. That is going to give you some summary statistics. And if you want to calculate some confidence levels or like kth largest or smallest values, you can do that as well. So once you click OK, yeah, you're gonna see this information in front of you, which is like some of the descriptive statistics. So here you can see you have like four columns in front of you. The first one is shows the total revenue in $1,000 with some statistical measures, and similarly you have the variable of grants donations that your beneficiaries have received in $1,000. So I would just briefly interpret each and every statistical value here so that you can like get a gist of what these statistical values or measures mean. So the very first one is mean, which is basically the average value, so which is 99.25. So it means that on the average, your beneficiaries or the respondents of your survey have generated 99,000 and 250 US dollars in a year. Standard error, which is 2.76, 2,760 US dollars, which is basically a measure that if you change the sample, um, if you select another like 30 beneficiaries other than these beneficiaries and you calculate their averages, then your average is going to change by this much value, like 2.76 thousand US dollars. The median is the point where it divides the whole data into two equal parts. So 50% of your population lies below that, and 50% of your responses are above that value. So this central value is $99,000, $99.7 thousand. And you can see there is no mod. Mod is basically the most frequent value occurring in the data. And there is no mod because there is no such value, not a single value that is being repeated again in your data. But if you have any value that is being repeated again and again in your data, it will pop up right here. Standard deviation gives you the measure that on the average how much your values vary from your mean value, from your average value. So on the average, values vary from your mean value by $15,140, like $15.14 thousand. Your sample variance, which variance is basically the square of the standard deviation, which is also another measure of spread in the data or the variability in the data, which is $229,000. Then comes kurtosis and skewness. These are the terms to know that whether your distribution is normally distributed. If you plot your data points on a graph, then if it shows a bell-shaped distribution, that we consider it as a normal distribution, or it has symmetry as well. So the skewness would tell you that whether your distribution is negatively skewed or positively skewed, or is it a symmetrical distribution. If its value is close to zero, it shows that your distribution is approximately normally distributed. For kurtosis measures the peakness of the distribution, that whether your distribution is like leptokurtic, mesokurtic, or platykurtic. If it is the ideal shape, it would be mesokurtic, like um, not very flat, not very high, like right in the middle. So it would be mesokurtic. Otherwise, if it is highly peaked, it would be leptokurtic. If it is relatively flat, it would be platykurtic. And the value closer to 3 shows that the distribution is mesokurtic. A range tells you the difference between maximum value and minimum value. So there's a difference of $48,000, $48,460 to be exact. The difference between your maximum value and your minimum value. The minimum value, so the minimum revenue that any of the businesses have generated is $74,000, $74,230, and the maximum revenue that any business has generated that you have supported is $122,690. And sum and count. Sum is obviously the total of all the values, and count is the number of observations that you have considered. Same goes for grants and donations. You can interpret these measures for grants and donations as well in the similar manner. So now coming to gender comparison for annual revenue. So for example, we have set certain questions for us to answer after we conducted the survey and after we carried out our analysis. So the first question that we have with us is that, is there any difference in the revenue of male and female beneficiaries? Secondly, is that difference significant? If there is a difference, is that significant or not? Sometimes the difference is just negligible and it is not like considerable. So we got to answer that question as well. And the third question that we have is, do the male beneficiaries earn more than the female beneficiaries? This is what our organization is interested to know, that whether male beneficiaries or male respondents are earning more than the female beneficiaries that we are supporting. So in order to answer these questions, we have this statistical tool available with us, which is called two sample t-test. So this statistical tool helps us to draw a comparison across two categories. For example, the question that we have, that whether male beneficiaries have generated more revenue or whether female beneficiaries have generated more revenue. So this question can be answered using this statistical test, which is called two sample t-test, which compares two categories in the population. So let's see how we can apply this statistical test in MS Excel. So for example, you have to arrange your data in this form where you have revenue for male beneficiaries in one column and revenue of female beneficiaries in another column. Then you need to select the variable ranges. So you have to provide the variable 1 range here, which is revenue for male beneficiaries, and variable 2 range, which is the revenue for female beneficiaries. Hypothesize mean difference, you can place a 0 here because you are testing this hypothesis. The null hypothesis, you have two hypotheses. The first one is called null hypothesis, the other one is called alternative hypothesis. So your null hypothesis states that the female beneficiaries are earning as much as the male beneficiaries, or in other words, that there is no difference in the revenue of male beneficiaries and female beneficiaries. Both of the genders are generating the same revenue in your population. And you have to check this option of labels, which shows that your columns have labels in the first cells. Alpha, which is a standard measure, which is also called type 1 error. The standard value for that is 0.05, which is like 5%. You can also call it margin of error. And then you need to provide an output range. So you will select the cell where you would like your output to be pasted against the hypothesis. Your null hypothesis states that male and female beneficiaries have same revenue, against the alternative hypothesis that male beneficiaries have greater revenue than female beneficiaries. So let's see what the results say. So you're going to see this kind of output in front of you, where you have some results of t-test. So two sample t-test assuming equal variances. So you can see 3 columns in front of you. The first column provides some statistical measures. which is like mean, variance, observations, pool variance. I'll talk about each and every one of that statistical measures. But you don't need to focus on each and every one of these measures. You just have to focus on like a couple of these measures to reach to a conclusion. And then in the next column, you have revenue of male beneficiaries in thousand US dollars and revenue of female beneficiaries. So let's talk about the mean values for both the male and female beneficiaries. So you can clearly see that the average revenue of male beneficiaries that they have generated is $54,200. And the average revenue of female beneficiaries is $47,850. So apparently, you can see that there is a difference between the revenues of male beneficiaries and revenues of female beneficiaries. But the question is that difference statistically significant? And secondly, is that generalizable to the target population? Because remember, in our hypothetical situation, we assumed that we conducted a sample survey. So we collected a sample out of our target population of, let's say, 100 beneficiaries. So this is a sample. So, in order to say that our sample statistics are generalizable to our population, the results have to be statistically significant. So, let's see if that difference is statistically significant or not. So, we'll talk about that, but let's briefly discuss variance and other statistical measures. Variance, as I already told you, that is a measure of dispersion, like how much dispersed your data set is. Observations indicate the number of observations in every category against every category. For example, you have 15 responses against the revenue of male beneficiaries and 15 responses that you have for the revenue of female beneficiaries. Pooled variance is the combined variance for both the categories. Hypothesized mean difference is zero because we are testing the null hypothesis that there is no difference between the revenue generated by male beneficiaries or the revenue generated by female beneficiaries. So that is the reason the hypothesized mean difference is zero. We have degrees of freedom, DF, which stands for degrees of freedom, which is 28. Its formula is n minus 2. N is basically your total number of observations, which is 30 in total. So if you subtract 2 from 30, it becomes 28. T-test is the statistical measure, which is 2.36 here, but we don't need to interpret that because we'll be interpreting based on the p-value, which is right here, 0.01. So we have p-value one tail, then t critical value of one tail, then we have p-value two tail and p critical value of two tail. But we need to focus on the first p-value. The reason to focus on this value is that our alternative hypothesis states that the male beneficiaries are generating more revenue in comparison to female beneficiaries. So because it is like a one-sided hypothesis, because we are saying that one category is greater than the other category, so this is kind of a one-tail hypothesis. So if our hypothesis was that female beneficiaries, the revenue generated by male beneficiaries is not equal to the revenue generated by female beneficiaries. That is, if we had not specified that direction, that one category is generating more revenue than the other category, then in that case, we would have looked at the p-value two tail. So it actually relates to our the direction that we provide in our alternative hypotheses. And how do we conclude that which of these hypotheses are accepted and which of these hypotheses is rejected? The rule of thumb is that you have to look at the p-value. So the p-value that I have highlighted here, if this p-value is less than 0.05, which is your level of significance, which is your alpha that we specified in when we were asking Excel to conduct this analysis. So if this p-value is less than the 5% value of which is the level of significance, then we will reject our null hypothesis. And if you remember, our null hypothesis was that the revenue for both the categories is equal. So in this case, our p-value is 0.01, which is uh, less than 0.05, which is our level of significance. So we can confidently reject our null hypothesis, and we will conclude that the revenue of male beneficiaries is greater than the revenue of female beneficiaries, which was our alternative hypothesis. So I'm going back to that slide. Very quickly. Yeah, so here our null hypothesis was that male and female beneficiaries have same revenue against the alternative that male beneficiaries have greater revenue than female beneficiaries. So now focus on this slide again. As we have said that based on our rule of thumb, which is our p-value is less than 0.05, which stands true, we are rejecting our null hypothesis. So we are assuming that the revenues across two categories is not equal, and the difference between the two categories is considerable, is significant, is there, is cannot be neglected. So we will conclude that our null hypothesis does not stand true against our alternative hypothesis. So our male beneficiaries are generating more revenue in comparison to our female beneficiaries. So now you can see that how useful this statistical tool is to provide you an insight based on the data that you have collected, that where your beneficiaries stand, and what is the result of your activities, what is the impact of your intervention so far. So now comes the question that what if you had more than two categories in your data with you? For example, if you had like multiple ethnic groups or like multiple cohorts, multiple locations, then which test will can help you to draw a comparison across more than two categories? So the answer to that question is that you have a test which is called analysis of variance that I mentioned earlier, but since we are not discussing that test, but briefly, if you have more than two categories to compare, then definitely you have to use analysis of variance. So thank you for that, and this is the time for questions. And
Thank you so much, Ishaq, for this insightful presentation. I'm sure if any of our fellows have questions, they will write them down because we are exceeding time. Thank you so much, Ishaq.
Thank you so much, Owens, and thank you all. And just briefly, I would say that I'm going to conduct a session, another session on some of the Excel tools like pivot tables and how to generate dashboards in coordination with Tech Committee. So, particularly DC fellows, if you are interested, you can attend that session to know more about how to develop basic dashboards in Excel and how to use pivot tables and other like statistical tools.
Awesome. Thank you so much, Ishaq.
Thank you so much.
Until the next webinar.